So what do you do when a secondhand auto lift from the auction arrives without a hydraulic pump to lift it? Well, buying one would just be too easy. So why not take a bunch of misfit parts and turn them into something useful? If you haven't noticed, online auctions can be a dangerous thing. That's kind of how I ended up with a second-hand 4-post lift. And the one thing that did not come with the lift is a hydraulic pump, though. Now you can go online and just buy a hydraulic power unit to run one of these lifts. However, the affordable ones come straight off the boat from China, and they're kind of questionable quality. Even some of the better import ones are approaching $500. You can buy the name brand, but boy, you're talking big bucks then. Not worth buying a second-hand used lift at that point. So I was racking my brain on ways to make a homebrew hydraulic power unit that didn't cost an arm and a leg. And eventually I thought of power steering pumps. Those are just small hydraulic pumps. Did some research on the basic lift parameters. Sounds like a lot of times the lifts may actually be running up to 2,000 psi for full capacity. The power steering pumps are running around 1,500 psi, but there's actually a relief valve in there, so might be able to kind of override that a little bit and get a little bit extra pressure if need be. So why not give it a try? We're going to try and just source all secondhand used or free parts for this build and see if we can't come up with a hydraulic power unit that can run the lift. Now the heart of this build is going to be a fairly substantial electric motor. I believe this came off of, actually I don't know what that came off of. Okay, on second thought, maybe that was from a homemade belt sander of sorts that was already half destroyed, and I was scrapping all the frame and everything else on it, but the motor looked too good to throw away. I think it's about maybe a 1 horse or 3/4 horse 220 volt motor. And the other side is going to be a power steering pump of some sort. Now this one here was originally what I was going to use because I found it next to a trash can, but it's got a serpentine pulley on it and have not had much luck trying to get this pulley pulled off of here and swapped out. So this may or may not get used. We might have to throw another alternate power steering pump on there. Another thing that came out of the deals pile from years back, because that's why you always stock up on deals when you get them, is I had this hydraulic control valve here. Now it might be slightly broken. The lever is no longer attached. I'm sure we can figure something out with a hose clamp and still make that work. But that's basically it. Electric motor, pump, control valve, maybe some gauges are interconnecting various randomness that we don't know yet. But there you have it. The scrap pile is an essential part of this build. Alright, some secondhand wire. Watch out for hornets. 14.2. Not really sure if that's heavy enough, but maybe we'll run the calculations later or just watch for heat and smoke. Got some random cheap bits off the internet. Welding cable end and a supposedly heavy-duty switch. Turn this sucker on and off. Got part of it wired up. Good enough. Alright. It's plugged in. It's live. Moment of truth, I guess. Ooh. It's spinning at least. So the other important thing to notice is if the power steering pump was mounted right there, that's actually spinning in a clockwise rotation. So I believe that's what the power steering pump wants as well. Got the subframe sort of figured out here. We're just scabbing on more pieces of scrap to try and mount things. As long as we have the pump mounted fairly solidly there. Probably going to put a couple of holes here, and the motor mount base plate has slots in it so we can adjust the belt. So we got the whole scrap base frame here mostly laid out. Motor mount is just bolted to the side there. Other side's free floating. That's for vibration dampening. Even though those angles are just tacked in there, power steering pump's close enough to make sure everything's going to be aligned and working. Yeah, close enough. Now if you look at the pictures online, I'll say that 220 volt motor that comes with the Chinese kit, it's nowhere near the size of this. So just by direct comparison, hopefully we've got enough horsepower to run this thing. And if it doesn't, we'll just adjust the belt ratio to get the requirement we need. So the first test did not go well. I was going to record the test run, but apparently there was still some fluid left in the pump. The 14 gauge wire, which we thought with 220 volt would be plenty, it's not enough. It's getting really hot really fast, and the breaker ended up tripping. So that's bad. After messing with it a couple of times, well, the on button is stuck permanently in the on position. Yeah, that's not good. So oddly enough, if you look down in there, you see that kind of charred terminal. The ground was actually overlapping and hitting that terminal right there. I believe it's wired up for 110 instead of 120. Got the wiring reset up so this thing is actually going to run on 220 now. I mean, before, yeah, there might have been a ground that was shorted out internally. Well, now we just have easy access to the ground in this wire here. Alright, so now we're on to the broken valve here. There used to be a piece of casting that went the whole way around, and it held that captive, so you could rock that back and forth with that little chain link right there. Well, what we did is we pulled the pin out of the bottom, and we're going to make something that goes across through there, and it goes down underneath that bolt that's holding down the end piece, and conveniently there's an extra threaded hole on the opposing side. So we'll just bridge the gap, and this thing should be good as used. Was able to make that, throw in this old 3/16 machine screw, and we're back in action. Gonna just throw the valve probably right up on there somewhere. I mean, we're not really planning out the whole layout, it's just kind of where pieces fall. Got a belt from the pile. Now the power steering pump likely won't have quite enough PSI in stock form to lift that whole thing up. So this is the relief valve right here. And you take this apart, there's a spring and a check ball and a seat. And underneath the screw right here are a couple of shims. We're going to pull those out and maybe even have to grind on this thing a bit to see if we get the pressure we need. Probably not good to be overdriving this pump and running it at a significantly higher pressure than it's made. I think around 1200 psi is probably where it's at. We're going to be getting up into the 1500 to, well, maybe even 2000 if we can get their psi range. But pumps are cheap, and we're not going to be running this thing on a constant basis, so it might survive. There's those shims. And there's the check ball. There's those pieces, and there's a little orifice inside here underneath that screen that all the pressure flows through. Now hopefully just removing these factory shims doesn't change it enough to start coil binding the spring, but that can happen, I guess, if you put too long of a spring or compress it too much. So we'll have to check through that little port window there and make sure that the spring is not coil bound. And there's just a skosh of daylight between them coils, so good enough for the first trial. Now up to this point, one of the most challenging parts has been trying to go from the pressure output of the power steering pump into an NPT thread. Seems simple, it isn't. So like the power steering hose that came with the pump has the fitting that goes into the power steering pump. Out to there has some kind of weird compression fitting that bolts onto that, and then another flare fitting with an unknown thread size. Now, being that this is 3/8 inch tubing, was able to source a 3/8 inch inverted flare fitting, and guess what? That fits perfectly onto the part that goes into the power steering pump. However, the part that exits is just slightly too large and will not work. Maybe it's 11/16 inverted flare thread for a 3/8 inch tube. But back to the drawing board on trying to find fittings. Alright, so I spent like another 10 minutes looking for fittings, and when I started seeing fittings for $32, we just broke out the saw, chopped that fitting in half, stole the other 3/8 by 5/8 nut off of the return line, because you don't really need a special fitting on the return line. We can plumb that in however, and just sort of scab that together. So now this goes on to the power steering line, and that should go into the NPT adapter right there. Alright, so time will tell if that leaks. Got the base frame welded up, got the new adapter hose from pump to NPT sort of mocked up. Still got to get a couple extra fittings here, don't quite have all the sizes. Now another part that we might end up needing for this whole build is some type of a flow control for when this lift wants to go down. If you just slam this valve down, I can see that thing just whoosh dropping. So was able to go on eBay, pick up a used one of these. It's basically a glorified needle valve. It's got a metered flow that you can change only in one direction, unfortunately, but we'll set it so that you can limit the amount of fluid flowing out of the cylinder back to the return tank. That should keep any violent drops from happening if you throw the valve too quick. And speaking of a tank, the stock reservoir in the power steering pump's not going to have nearly enough fluid to throw a sizable hydraulic cylinder. So went through the randoms pile, found an old gas can. Yeah, we'll just sort of throw that up there somewhere on top, and that should be good enough. What I'm thinking is we can use the existing return line from the power steering pump. Since it's tapped into the reservoir, we can tee it off between the return line that comes out of the valve and put one line down into this tank. It'll be a siphon effect. When it needs more fluid, it'll draw it right out of the tank through the pump out to the cylinder, and when it drops, it'll come back out through a T right back into the tank. Threw one of these glass fuel filters on here to try and get some of the crud out of the line returning into the fuel pump here. Yeah, apparently these aren't the greatest to use on vehicles because they have a tendency to crack, break, or start a fire, so yeah, it should be good enough for this safe piece of equipment. And there's the permanently temporary reservoir solution. Don't worry, that's a good USA made bungee cord. Now I know you're not supposed to use Teflon tape on hydraulic stuff. We're just being really careful. So pressure's coming in from the pump to the valve. When it switches to go up, it should pressurize this port and go to the cylinder on the lift. I temporarily have that port blocked there since this is a single acting cylinder. Gravity brings it down. If you want to plumb this in and run dual directions, you just have your B port there. Now the return line, since it's non-pressurized, doesn't need to be any crazy hose or special fittings. So we just got a barb here that we're going to run and tee it right here. Alright, almost time to fire this thing up and see if it resembles a hydraulic fluid lawn sprinkler. And maybe see if that $5 power steering pump actually even works. Probably should clean out the tank, but, well, that's why there's a filter. Now for testing, we just got the output looped right back into the reservoir tank. So we got a mystery jug here. some second-hand oil that was, I don't even know where it was sourced actually. It says it's possibly hydraulic fluid. Problem solved. That's what we're going to use. Yeah, I'd say that's close enough to oil. That might be motor oil. Now we're going to have to find a way to seal off the top of this power steering pump reservoir down here. I bet you the cap's vented. Well, time to find out how much of a mess this thing makes. If the switch works. Okay, well that's an issue. So you can tell by the discoloration, these two terminals were taking a lot of heat when the ground wire was shorted out. It's even melting some of the plastic there. We're going to have to buff up those contacts and remove some of that melted plastic to try and make this thing work. Not buying a new switch. Now we got them contacts freed up. Lost a spring in the process of working on this switch, but was able to make something else work. Springs from those clicker pens often come in handy. Had to modify this cap. There was actually a couple of little notches right there that allowed air to go underneath the rubber gasket. So we had to tear this whole thing apart, cut off the dipstick, and throw some RTV underneath the rubber gasket to seal off that passageway. So hopefully this is a fully sealed cap at this point. Alright, better fill it up. Even with the cap on there, every time it would run, the fluid would slowly drop and then it would suck air. So it was putting more fluid back out into the reservoir tank here than it was going in a loop. So hopefully this is the solution to the cap problem. Got a piece of radiator hose and a hose barb that has a clamp to go through a bulkhead. Now we just jammed some washers, and there's even an O-ring sandwiched in there to seal this barb up to that washer and seat it down into the hose and replace that piece of inner tube that's temporarily been trying to seal that. Now since this will have the barb up top, we're going to rearrange the return line, cap off the reservoir, and try and run the return into the top here. Hopefully that also has a self-bleeding feature, as the air should sort of, well, run back up into the hose a bit. Try and disconnect all this stuff without spilling 2 gallons of oil on the ground. It's just dust control. Times Beach, anyone? Turns out there was a whole lot of bugs in that oil, so we did have to give it a filter. Had the first reenactment of Old Faithful. Blew off that return line there when apparently the filter was just adding too much restriction. I think we coated the roof a little bit. That's just free undercoating. Well, overcoating in this case. So sometimes in a project like this, you just encounter problems that you didn't expect. And one of those problems was the suction for the return line to go back into the stock power steering reservoir there. It was always pulling a vacuum and was creating air leaks. It wasn't working. We always ended up with an air pocket down inside, like the top right there. So we're going to solve that problem and just make the entire tank the reservoir. Got to make a mount, just flip this up, and then you're going to have a whole 1.5 gallons of oil just directly force fed into the top of the power steering pump. That solves that, I guess. Alright, it's plumbed in. Working so far. Now you can't lower it while it's running because it just deadheads the pump because we got that other port blocked. So when you shut it off, then you can let it down. There's got to be a whole lot of air in that line and in the cylinder, so having the self-bleeding style reservoir up top, it's probably going to make life easier in the long run anyways. Got to do something slightly more permanent than that though. I mean, one bungee cord's fine, but when you got to start doubling them up, well, that's just sloppy fabrication. Adjustment on the outflow seems to be pretty good. It's relatively slow going down, so it doesn't need to be any quicker than that. Gonna get the rest of the lift sort of finished up, make a mounting stand for this thing to put it kind of next to it over here, and then we'll find out when we put a real heavy vehicle on here if that thing's got enough oomph. If not, we're gonna go back in, grind a little bit off of that pressure valve and try and see how much we can boost the pressure up. Even though this whole thing was created for a lift, it's going to be real handy having a little portable, I mean, depending on how strong your back is, power unit to take around in case you need to run some cylinders or a hydraulic motor, move some farm implements that you don't have a tractor or skid loader right next to. And that whole setup just looks a lot more professional than some power units stuck to the side here. Not going to know how to work at this level. Well, now that the pump situation is sorted out, here's a quick rundown of how the rest of the lift came together. Some assembly required. Now you might be saying, don't you need a whole concrete floor? Well, hopefully not. So these are some 18 inches by 18 by 6 plus concrete footers. And there's actually 4 strategically placed pads. Measured the spacing at least 3 times, so they better be right. There's the CAD layout. Problem with some of these rollers is the bushings are just really worn out and they're sort of loose inside the bore. I mean, they just fall out. Those should be press fit into the rollers, and well, they shouldn't have pieces missing out of them either. So went on the old McMaster car and was able to find some exact size replacements, jam in there. Now, being that the inside's probably wallered out and the bushings aren't going to just get nicely press fit in there, we're going to clean this out, probably put a bit of JB weld and permanently seat those things back in there. Now, some of the pins have wear just on one side primarily. We're going to try and flip these all around so that the load bearing side has a fresh surface to grind into. That's how you got to extend the life of used and worn out parts. So after getting all the pulleys refreshed, had to add a couple of extra idler ones there, resort the spring situation and make sure everything was up to par. Had to weld up one of those locking dogs because it was worn from over the years of going up and down through them slots. Even though the cables were pretty old, they didn't have any fraying and looked pretty solid, so we gave them a coat of oil to keep any rust from forming. The old air cylinder attachment here that would basically be powered by an air line, and it would release all of these latches here when you want to lower the lift. Well, that was all not functional. Those cylinders are expensive to replace. They don't often work. So whatever. Basically, we drilled a hole and put a nail here, and when you want to lower the lift, you have to manually pull these back, insert the nail to kind of hold this latch open, and then the lift can lower. Yeah, it's a bit of a hassle, but it works. Another addition was something thanks to the holiday season. Wired up some Christmas rope lights along the runways here. And it actually gives a bit of light underneath now. So to basically wrap up this project, you could add up all the time and the parts that went into it. Pretty much about $65 or so is the total investment. Had a lot of things like that valve laying around. All the other bits and pieces were pretty much accumulated from the junk pile. That's why you don't throw stuff away. Sure, just going out and buying one of those pumps would have saved a lot of time. Probably had about 3 weeks or so just waiting for little bits and pieces, parts to come in the mail, figure it out, and actually put some effort into putting this whole thing together. But it's more than that. Not every project is worth taking a whole lot of extra time like that. But some projects just have a lot more value in the things that you learn and the experiences you get when you're trying to get them completed. I've had people ask, how the heck did you know that about a certain thing? Well, it's generally just because I was dumb enough to think that I could figure it out. Now, that's not to say that every project's going to work out perfectly and have a great solution to it. Sometimes things fail. They don't work out the way you want, but there's still always usually something that you can glean from it and apply to a future project. Running into some hardships and problems, putting together something like this, that's usually when you end up learning the most. Found out about the odd-sized fittings and power steering pumps. AC power motors is not one of the things that I'm used to working on, but was forced to actually figure a few things out and find some wiring problems. Figured out some of the do's and don'ts of hydraulics, and just general assorted hackery. So don't always assume that cheaping out is just about saving money. Sometimes it's about the process of learning something and fixing it yourself. Granted, it's nice having those few extra bucks in the old pocket,